Imagine this. You board a spacecraft on Earth, press a single button, and in just a few moments, you step onto a planet millions of light years away from our galaxy. A world where the clouds are blue and the grass is purple. A distance that would take the fastest thing in the universe. Light, millions of years to cross. You covered in the blink of an eye. Is this magic or a hidden shortcut of nature? In the world of science, this miracle is called a wormhole. In today's video, we will uncover the scientific truths hidden behind this mysterious tunnel. Welcome back to Mystery in the Dark. Perhaps the most amazing thing about our universe is its unimaginable size. The universe is so vast that it is difficult for the human mind to even conceive it. But perhaps this is also its most disappointing aspect. Think about it. If today we used our most advanced telescopes to find a habitable Earth-like planet in another galaxy, it would still take us centuries to reach it. In fact, with our current technology, leaving our own galaxy seems impossible for humans. As everyone knows, our Earth is located in the Milky Way galaxy. The closest galaxy to us is the Andromeda Galaxy, which is approximately 2.5 million light-years away. If we used a conventional spacecraft traveling at 28,000 kilometers per hour, it would take us 94.5 billion years to get there. Even if we somehow developed technology to travel at the speed of light, it would still take 2.5 million years. It feels truly disheartening. What is the point of finding these planets if we can never visit them? But friends, if there were a shortcut in the universe that could help us travel across millions of light years in just a few months or minutes, then things become very interesting. These shortcuts are known as wormholes. Science and wormholes. In the famous film Interstellar, it is shown that Cooper and his team reach another galaxy in a matter of minutes through a wormhole. According to the movie, NASA discovered this wormhole near the orbit of Saturn. The most fascinating part is that the concept of wormholes is not just science fiction. It is based on real science. To understand this, we must look deeper into Albert Einstein's theory of relativity. When Einstein wrote his field equations, he explained how matter and energy influence the curvature of space-time. He suggested visualizing space-time as a large mesh or fabric. When a heavy object is placed on it, the fabric curves under the weight. The greater the gravitational force of an object, the more the space-time fabric curves around it. Einstein himself was unable to fully solve these complex equations. In 1916, Carl Schwarzschild found an exact solution that led to the concept of a singularity. He showed that if mass becomes infinitely dense, space-time wraps so tightly that it pinches off from the rest of the universe, creating what we know as a black hole. Just as black holes were a theoretical solution to these equations, another solution is the wormhole. But here's a question that might blow your mind. If Einstein's equations allow wormholes to exist, why haven't we found one yet? The answer lies in a massive cosmic hurdle called stability. You see, a natural Einstein-Rosen bridge is incredibly fragile. Mathematical models suggest that these tunnels collapse so quickly that not even a single photon of light could make it to the other side. Imagine a door that slams shut in a trillionth of a second. That is the reality of a standard wormhole. To keep such a tunnel open for travel, we would need a very specific kind of substance known as exotic matter. Now, this isn't your everyday matter like atoms or molecules. It is a substance with negative energy density that pushes the walls of space outward. Without this cosmic glue to hold the tunnel open, any spacecraft attempting to enter would be crushed instantly as the wormhole snaps shut. But the mystery goes even deeper. Because a wormhole isn't just a shortcut through space, it is potentially a time machine. The legendary physicist Stephen Hawking explored the idea that if we could move one mouth of a wormhole at the speed of light while keeping the other end stationary, time would pass differently at each end. This means you could enter the wormhole in the year 2025 and exit on the other side in the year 3025, or even travel back into the past. However, traveling into the past brings us to one of the biggest headaches in science: the grandfather paradox. Think about it. If you use a wormhole to travel back in time and accidentally prevent your own grandfather from meeting your grandmother, you would never be born. But if you were never born, how did you exist to travel back in time in the first place? This is why Stephen Hawking proposed the chronology protection conjecture. He suggested that the laws of physics might actually conspire to destroy a wormhole the moment it becomes a time machine, perhaps through a massive burst of radiation. It's as if the universe has a built-in safety switch to prevent us from messing with history. And yet, there is another mind-blowing theory. Some scientists believe that wormholes are already all around us, but they are microscopic. According to the theory of quantum foam, if we look at space at a scale smaller than an atom, tiny wormholes are constantly bubbling in and out of existence every billionth of a second. The ultimate challenge for a future civilization would be to find one of these tiny holes and stretch it wide enough for a human ship to pass through. Understanding a wormhole is quite simple. Imagine 2 points, A and B, on a flat sheet of paper. In 2 dimensions, 2D, the shortest distance between them is a straight line. But if we fold that paper and bring the 2 points close to each other, we can poke a hole through and reach from one point to the other instantly. This shortcut is a wormhole. In our 3D world, we think the path to Andromeda is 2.5 million light-years long. But if our space is curved through a 4th dimension, a wormhole could provide a much shorter path. In 1957, scientist John Wheeler compared this to a worm eating through an apple. Instead of crawling all the way around the surface, the worm travels through the middle to reach the other side faster. This is where the term wormhole originated. In reality, because a wormhole works in 3D/4D space, it would look like a spherical ball rather than a flat hole. The big question is, can humans actually travel through them? To create a wormhole opening, an extreme gravitational force is required, which is found in black holes. However, a black hole is a one-way street. If you enter, you can never get out. For a wormhole to work as a tunnel, there must be something at the other end that acts as the exact opposite of a black hole. Something that pushes matter out instead of pulling it in. This is called a white hole. A white hole is also a theoretical solution to Einstein's equations. It is a region where matter and light can only exit, never enter. Some scientists believe that when a black hole dies, it spits out all its internal information and matter through a white hole. While we haven't found definitive proof of white holes yet, a mysterious burst of light detected in 2006, GRB 060614, is considered by some experts to be a potential observation of a white hole. For now, wormholes exist only in theory. However, history shows that black holes were once just a theory too, until they were proven real. In 2015, scientists even successfully created a magnetic wormhole in a laboratory, which could transfer a magnetic field from one point to another through an invisible path. Even if wormholes are never proven for human travel, Other theories like the Alcubierre drive suggest ways to contract space-time to travel faster than light. It will be incredibly exciting to see what other practical wonders we derive from these scientific equations in the future. But wait, before you leave this dark corner of the universe, I want to leave you with a thought that has haunted scientists and philosophers for decades. Imagine for a second that a stable wormhole is actually discovered tomorrow, right in our solar system. It's an open door to a galaxy millions of light years away, a place where no human has ever breathed and no telescope has ever reached. Here is my question to you. If you were offered a one-way ticket through that wormhole, knowing that you might discover a new home for humanity but would likely never see Earth or your loved ones ever again, would you take that leap? Is the thirst for discovery stronger than the fear of eternal loneliness? And let's push the mystery even further. We talked about the grandfather paradox. If that wormhole was actually a bridge to your own past, and you had the chance to meet your younger self or a lost loved one, but doing so could potentially collapse the entire timeline, would you risk it? Would you prioritize a moment of personal happiness over the safety of the entire universe? I truly want to hear your theories on this. Are we, as humans, brave enough to handle the power of a wormhole, or are some doors in the universe better left shut? Write your answers, your theories, or even your wildest space dreams in the comments below. I'll be jumping in to read and reply to your thoughts, and I can't wait to see the debate this sparks. And if you're still craving more mysteries, make sure you're subscribed to Mystery in the Dark. We have so many more shadows to explore together. I'll see you in the next mystery.